last video was a proof of the law of sines, which helps us solve some oblique triangles. But some oblique triangles require us to use the law of cosines, in particular in the case of side, 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 or side angle, side, as the given information. So to prove the law of cosines, we start with a right triangle A, B, C, and we draw in the auxiliary segment BD. And what that does is it gives us two cases of the Pythagorean theorem to consider. Namely, we can consider BD squared. That has to be equal to BC squared plus CD squared. Moreover, we can say AB squared has to be BC squared plus AC squared, or CA squared. Okay. Now, we can actually make a substitution here. We can take the second equation and solve it for BC squared. In particular, BC squared has to be equal to AB squared minus CA squared. And then I substitute this in for BC squared here. So what I'm left with is BD squared is equal to AB squared minus CA squared plus CD squared. Now what we have to look at now is that there's another substitution to make here actually. CA, this length right here, is actually CD plus DA. So I'm going to substitute CD plus DA in for CA, and that's by something called the segment addition postulate. So BD squared is equal to AB squared minus CD plus DA squared plus CD squared. Okay, so now we're going to square this binomial, which means we multiply it by itself, and we have to actually FOIL that. So we have BD squared is AB squared minus, when I square this thing, I get CD squared plus 2CD DA plus DA squared, that's plus CD squared. Okay, so distribute this minus sign. So I have BD squared is equal to AB squared minus CD squared minus 2CD DA minus DA squared plus CD squared. Take a look. We can actually simplify this a little bit. There's a negative CD squared here and a positive CD squared there. So those are going to cancel. And finally what I have is BD squared is equal to AB squared minus 2CD DA minus DA squared. Okay, we're going to have to make another substitution, but to make that substitution, we need to recognize that the cosine of A, the cosine of angle A, is the adjacent over the hypotenuse for the right triangle ABC. It's going to be CA over AB. But remember that CA, we can use the segment addition postulate to substitute CD plus DA in for CA. So this is CD plus DA over AB. And now let's solve this equation, cosine A equals CD plus CA, CD plus DA. That's a D. Let's solve this equation for CD. So I would multiply both sides by AB, so then I'd have AB cosine A equals CD plus DA, and then subtract DA from both sides. So I finally end up with CD equals AB cosine A minus DA. Okay, good. Now let's substitute this in for CD right here. We want to do that because we're trying to solve the law of cosines. We're trying to prove the law of cosines for this oblique triangle, triangle BDA. It doesn't make good sense for us to have this segment CD involved there. Okay, so we make that substitution, and we get BD squared is equal to AB squared minus 2 times AB cosine A minus DA. This is times DA. This is minus DA squared. Okay, so I'll distribute the 2 here. And I have BD squared is AB squared minus 2AB cosine A. Now plus, this is plus 2DA, and that's all times DA. Excuse me, this is, yes. This is all times DA. It's minus DA squared. Now distribute this DA to this term and this term. So I have BD squared equals AB squared minus 2AB DA cosine A plus, this parentheses should, yes, well, this should have been distributed in the step prior. I shouldn't distribute that minus to that. I've already distributed that. So that's plus 2DA squared minus DA squared. 2DA squared minus DA squared is 1DA squared. So I'm left with BD squared equals AB squared plus DA squared. I had 2 of them, I subtract 1 of them, I get 1 of them, minus 2AB DA cosine A. And that actually concludes the proof for the law of cosines. There's a lot of substitution there. And the key is to think of really 2 things. Well, the most important thing is perhaps drawing in that auxiliary line and understanding that we have 2 right triangles to consider here, and then making the correct substitutions with the segment addition postulate, thinking that AC is in fact CD plus DA. So there you have it. That's the proof of the law of cosines that will help you solve oblique triangles when you're given 3 sides or side, angle, side.